When we've talked about the voltage sources so far, we've talked about constant voltage sources, but commonly we get our power from the wall outlet, and what does the voltage out of the wall outlet look like? So if we would measure it on the oscilloscope, and usually you would have to maybe use a voltage divider to measure some reduced voltage on the oscilloscope, but if our oscilloscope went up to sufficiently high voltage, we would see a waveform like this, a sinusoidal waveform that would go up to about 170 volts, down to minus 170 volts. Notice I marked polarity on the probe. And it would go through a cycle every 1/60th of a second. Right? There are multiple historical reasons why the power is at 60 hertz frequency. One of which is the fact that this would ensure that there is no flicker in the lights because our eyes don't respond that fast. All right, so notice again that I wrote down 170 volts. So why is it often referred to as 120 volt waveform? Okay, so if you ask what's the power output out of the wall plug, most people would say 110 to 120 volts. Why is it like that? All right, so before we get into it, let's ask ourselves, what is the peak instantaneous power absorbed by a 250 ohm light bulb? So power peak would be the maximum voltage squared divided by the resistance. And as you can see from the waveform, the maximum voltage is 170 volts, so it would be 170 squared divided by the resistance of 250 ohms. And you would find that it's about 120 watts or so. Alright, that's the peak power, but as you notice, the power will vary, so we might ask ourselves, what is the average power? Right, and that's going to be the subject of the next part of the video.